So welcome to the video lecture series on finite languages and automata theory. In today's lecture, we will be learning about designing of pushdown automata for a specific context-free language. So the problem here is we are supposed to design a pushdown automata for a language pattern a to the power of n, b to the power of 2n, where n is greater than or equal to 1. So first we will discuss what is that language pattern which can be accepted, the legal language patterns which can be accepted. So when n is applied as 1, then we can have a, b, b. Okay. When n is equal to 2, we can have a, b, b. And when n is equal to 3, we have 3 a's and 6 b's, so on and so forth, because number of b's is actually 2 times the number of a's. So now to design the pattern, first we will try to simulate it in terms of stack. So initially a stack will be having a value called as z0. So initially a stack will be having a value called as z0. I will take a valid string called as a, b, b. Okay, two a's and 4 b's. I will take one valid string like this. Now when we read the input from left to right, so the first input is a, and the topmost symbol of the stack is z0. When we have z0, a topmost symbol z0. Now, in what way we can actually make this number of a's and b's equal? So, if we try to make this number of a's and b's equal, then we can easily pop it out, and finally we can empty the stack. So, that is the logic behind this. So, we have two a's and 4 b's. So, the only solution to this is when we have one input for a, we have to push 2 a's inside the stack, so that the number of a's inside the stack will be equivalent to number of b's. So, this is the logic behind this. For every 1 a, we have to push 2 a's here. So, when input is a, topmost symbol of the stack is z0. Now, we have to push 2 a's further. Okay. So, when we push 2 a's inside the stack, it will become a z0. Okay. Now, input is a now. The topmost symbol of the stack is a now. Okay. When input is a, topmost symbol of the stack is a. Again, we have to push 2 a's, so that for every 1 a, we will have 2 a's inside the stack. Okay, almost all the number of a's and b's will be equal here. Okay. So when I push a here, when I see a here, I still push 2 more a's inside the stack. So for every 1 a, we push 2 a's. Now almost we have altogether 4 a's inside the stack, so which is equivalent to number of b's. Now the rule here is when we read the input called as b, when the first b is there and the topmost symbol is a, okay, that means we have to pop the stack a out. When we pop this a out, so ultimately 3 a's will be remaining here. So 3 a's is remaining, and we have 3 b's. Okay, so we will repeat this process. When we repeat this process, 3 b's is 1 b is there, and when we pop this a out, now we have 2 b's and 2 a's. Okay, so when we keep on repeating it, finally we have 1 b and 1 a, and when we pop it out, and finally nothing will be the input here. The input is actually epsilon, topmost symbol is z0. When this is the state, okay, when this is the state, we go to an accepting state here. So this is the mechanism. So in this problem, when we have a number of a's, we want to make number of a's and b's equal. For every 1 a, we have to push 2 a's inside the stack. Okay, and for every b, we have to pop the a from the stack. Finally, we can empty the stack here. So we will solve this problem by empty stack concept. Okay, and the stack becomes empty, then we can accept the language. So now initially, as far as we are pushing inside, we will be standing in the same state. We will be standing in the same state. Let us assume that. So I want to push the element here. If I want to push the element, I will be standing in the same state. Okay. Now what is the first state here? So now input is a, topmost symbol is z0. Okay. So since I am pushing the number of a's inside the stack, I will be remaining in the same state. So I will go here. So first we will have initial state is q0. So delta of q0. So input is a, topmost symbol of the stack is z0. Okay, when this is the state, now I am not touching this z0. Z0 is actually as it is. Okay, but what happens in the next level? What happens in the next level? Actually, I push two more A's inside the stack. So altogether, the number of elements inside the stack Z is untouched, and apart from the two A's actually pushed inside the stack. So now you will be standing in the same state. So I go here and I make stand on the same state called as Q naught, and I make AA Z naught. So this is one transition function. Now I go to the next transition function. So how to write the next transition function? See here, input is A, topmost symbol is A here. Okay, that means this A is untouched, and apart from that, actually I am pushing two more A's here. Okay, this A is untouched, I am pushing two A's here. That means we have to altogether write three A's here. Okay, so this A is untouched. So what we have to do is we stand here, delta is equal to Q naught. We stand in the same state. Input is A, topmost symbol is A. Okay, so this A is untouched. Still, after this A, we have to push two more A's inside the stack. So don't touch this A. Let the A remains as it is. Then apart from it, push two more A's inside this. So altogether, it will be four A's here. So this is the second transition function. Now we'll go for the third one. So when we are having input as B here, input as B, when topmost symbol of the stack is A, we have to pop it out. Since we are popping out, we will be moving from one state to other state. That means you are in the state called as Q naught, we will be moving to the state called as Q1. So now I go to a state called as Q naught, input is B, topmost symbol is A, and we go to a state called as Q1, and we pop this A. When we pop this A, that means A is actually replaced by epsilon. So this is the concept. Okay, we have written the third transition function. Now we'll go for the fourth transition function. So as far as fourth transition function is concerned, it's going to be repeated because we are going to pop it out continuously for every B here. Okay, so remaining all functions, when B is actually encountered as an input and when A is the topmost symbol of the stack, we will keep on popping the elements and we will be remaining in the same state. Okay, so now we are in the state called as Q1. So delta of Q1, input is B, topmost symbol is A. So we keep on popping and we will be standing in the same state, epsilon. Okay. And finally, so there comes a situation when there is no B's here. Okay, there is epsilon and topmost symbol is Z naught. At that time, we have to go to the accepting state. Okay, that means we are standing in the state called as Q1. We will be going to a state called as Q2 and make that Q2 as an final state. So delta of, we will be standing in the state called as Q1, input is epsilon, and the topmost symbol of the stack is Z naught. So we will go to a state called as Q2, replace this Z naught by epsilon. So Q2 is called as a final state. Okay. Now we will draw this diagram. We will draw this diagram for this transition function. So how to draw this diagram? So we altogether we have 5 transition functions on 3 states, Q0, Q1 and Q2. So we will do one thing, we will draw the number of states here. Q0 is the first state, Q1 is the second state, and Q2 is going to be the final state. Now, see, check it out the states here. If in the first transition, Q0 is called as an initial state. Okay, we'll make this. So in Q0 to Q0, you are moving to Q0 to Q0 for the first transition. So you make a self loop here. Okay. So what is the input? A is the input. What is the topmost symbol of the stack? Z naught. So I can write like this: A, comma Z naught. Okay. And this Z naught is actually replaced by AA Z naught, isn't it? Okay. So below this Z naught, put a bar and write AA Z naught. Now go to the second transition function. So second transition function also remains in the same state, Q0 to Q0. So we have already one loop here. No need to redraw again. But see, what is the transition? Input is A, topmost symbol is A. Okay. So input is A, topmost symbol is A. Okay. Now this A is actually replaced by A. Okay, that A is untouched, and apart from that, two A's are pushed further. Okay, so I put a bar A, 3A's. Okay, now go to the third transition function. Transition is going from taking place from Q0 to Q1. So in Q0 to Q1, you make a transition function, a line. Okay, so what is the input? Input is B, topmost symbol is A. So input is B, topmost symbol is A, and this A is actually replaced by epsilon. That means you are popping A here. So this is a transition function, we are return it. Now go to the next one. Okay, go to the fourth transition function, Q1 to Q1. Okay, you are making from Q1 to Q1. So stand in the same, make a self loop from Q1 to Q1. So input is B, topmost symbol is A. Okay, input is B, topmost symbol is A, and this A is actually replaced by epsilon. So I replace by epsilon. Okay. And the last one, transition function, Q1 to Q2, making a transition from Q1 to Q2. So make a line from Q1 to Q2. And here the input is epsilon, topmost symbol is Z naught. Okay. So input is epsilon, topmost symbol is Z naught, and this Z naught is actually replaced by epsilon. That means I empty the stack. That's all. I go to the final state. So this is a diagram, pushdown automata for to accept the language pattern of a to the power of n, b to the power of 2n. Okay. Now we'll do one thing. We will actually simulate this with the help of any valid string. Okay. So we'll perform a simulation for this. What is simulation here? So simulation. I'll take up a valid string called as ABB. Okay, ABB is also a valid string, isn't it? Okay, so W is equal to ABB is called as a valid string. Now, how to validate this? Now, see here, if you want to validate this, we start from Q0 here. Okay, we'll start from Q0. Delta of Q0, input is ABB. Okay, and the topmost symbol is Z0. Initially, Z0 will be there. Okay. When input is A, topmost symbol is Z0. That means Z0 remains untouched, and further 2 A's will be pushed inside the stack. Okay. So we'll be standing in Q0 state, isn't it? So now we are going to a state called as Q0. So for every 1 A, we have to push two A's inside the stack. So what will be the remaining input? BB will be the remaining input, and 2 A's are pushed further inside the stack. So stack now will consist of AA Z naught. Now go to the next one. So input is B, topmost symbol is A. So now what we have to do? If input is B, topmost symbol is A, we have to make a transition from Q0 to Q1, and we have to pop this A out. Okay, isn't it? So now we will go here, take this tungsten symbol, use this tungsten symbol, delta of, so we will be making a move from Q0 to Q1, then this B and this A is popped out, okay, and this B goes off. So if this B goes off, what will be remaining? B will be remaining, and 1A goes off, so A is that not will be there. Okay, now we are in the state called as Q1. When input is B, topmost symbol is A. So we have to remain in the same state called as Q1, isn't it? That's what our diagram says. So now we will be moving to a state called as Q1 itself. Input is actually, if this B goes off, what nothing will be remaining, epsilon will be remaining, and this A goes off, Z naught will be remaining. Now we are in the state called as Q1. Input is epsilon and the topmost symbol is Z naught. That means we have to move to the final state. So input is epsilon, topmost symbol is Z naught. Move to Q2 state, and that is going to be a final state. Okay. So now since this is the final state, no transitions is required. Directly write Q2. Input is epsilon, and stack is actually replaced by epsilon. Okay. Hence accepted. Hence the language is actually accepted. This is how actually you can design a pushdown automata for a language for a to the power of n, b to the power of 2n. Thanks for watching the video. Have a good day.